Hi class. Today we are going to learn new data structure named binary trees. So a tree or trees, it is data structure which can be many different types of trees, but we are going to focus on binary trees. It's a little bit different from other trees, and I will explain you how it's different. So we already know linked list data structure, which uses nodes, and trees also use nodes. A binary tree is made of nodes where each node contains a left reference and a right reference and a data element. So if you remember linked list, and I really hope you do, for example, single linked list uses node which contains data and link or reference to next node. With binary trees, it's a little bit different because now we have node that contains data and link to the left and to the right nodes. So it is a difference. The topmost node in the tree is called the root, and we can see a root here. It's number 1. So it is a root. And here you can see the entire tree. So why is it binary tree? It's very important to understand. Binary tree can have 0, 1, or 2 children. At most, it has 2 children. So it cannot have 3 children. For example, you can see here only 2 nodes, or 0 nodes, 0 children. So let's move on. Every node, excluding a root in a tree, is connected by a directed edge from exactly one other node. And we can see edges here. Edge, edge, edge. Between nodes, right? It's link. This node is called a parent. On the other hand, each node can be connected to number of nodes called children. And I think I already showed you. Here's our nodes 1, 2, 3, 4, 5, 6, and 7. A node can be parent. For example, is number 1 is parent? Yes, because it has 2 children, node 2 and node 3. The same here, node 2 and node 3 are parents because they have children. But you can see that node 4, node 5, 6, and 7, they do not have any children. It means they are not parents. And also it means they are leaves. We call them leaves. So leaves are nodes with no children. We also call them external nodes. And nodes which are not leaves, they are called internal nodes. So if the node is not a leaf, it means it's internal node. And nodes with the same parent are called siblings. If they share same parent, they are siblings, or those two. So again, it is a tree. Node can have children, 1 or 2, and we call those nodes parents. Children, it means it has some link to the left and to the right node with actual nodes, right? And it's possible that node doesn't have any children. It means this node is a leaf. You can see bottom level. So some properties of a tree, it has depth, or some node has depth and height of a tree or of a node. And let's look what it is. The depth of a node is a number of edges from the root to the node. For example, if I want to calculate depth of this node, I need to calculate number of edges from the root to this node. And in this case, it's 1 and 2. So depth of this node is 2. The height of a node is a number of edges from the node to the deepest leaf. So let's say I want to calculate height of the same node. I just need to calculate number of edges to the deepest leaf, and deepest leaf will be here. So it's 1. Height of this node is 1. And the same height of a tree is a height of the root. So empty tree has height of -1 or -1 if the tree is empty. If tree has one node, it means its height is 0. But if it's more nodes, it means, so we need to calculate number of edges from the root to the deepest leaf, sorry. And binary tree can be full and complete, but we will talk about this a little bit later. You can see some examples here. So where do we use binary tree data structure? For example, in your computer, your folders and files, you can see here. So it's like a tree, right? File organization. If you're interested in artificial intelligence, you will see a lot of binary trees there, or decision trees. And of course, compilers. And about this, you will see, we will talk in Java tree course. So again, binary tree is a tree where each node has at most 2 children. If a tree has more than 2 children, it means it is not a binary tree. It's some other tree, but not binary tree. And this is very important to understand. And here's just a little bit different representation of nodes, because before we saw it as circles, nodes. But in reality, if you want to compare it to linked list, for example, you can see the same node with data and with 2 links, link to the left and link to the right. And here how your binary tree looks like. One node with link to the left and link to the right. And for example, node of the left, or I will call it left child, has the same node with the same content of the node, which is left, data, and right. Left, data, and right. And so on. That's how your actual tree looks like. And tree is a very powerful data structure, and I really like it, and I hope you will like it too. Yes, let's create some program with nodes just to see how it works. Some code example. So how do we start? Remember, we're working with nodes. It means that we need to create object node, just like with linked list. Public class, and I'm going to name it bnode, so we don't confuse with linked list. Okay, just bnode. It has value or data. Doesn't matter how you name it. It is your data, just like with linked list. So data that your node will contain. It can be integer, it can be any other data type, but I'm using strings. And I need two links, bnode left, and bnode right. References to the left and right child, to the right child and to the left child. So of course we need constructors. Public bnode, which is going to take string value as a parameter. This value and what was this left? This right set to the null. And then public bnode, another constructor. This time this constructor will take all the parameters, which is string value, bnode left, and bnode right. Just assign everything this value, this left and this right. So we are done with bnode class. Now let's test how it actually works. Oops. Bnode tester. Of course it's equals, not minus. Okay, so we created bnode object, and now let's construct a tree. I want this tree A, which has A is a root, has two children B and C. B has one child, which is node D, and C has two children E and F. Also D has one right child, which is G, and okay, something went wrong here. Yeah, it's better. So E has two children, H and I. F has one child, J, and J has one left child, K. That's the tree which we are going to construct, but we are going to do it by hand, manually. We're not going to use any methods for this. Why? Because we want to learn how manipulate a tree, how it works, how we can connect them. And then after we do it by hand, we will write some code to add, to link, and so on. So let's see. So how do we start? Create a class, public class. I'm going to name it bNode tester. What we are going to do, basically, we are going to test what we just wrote, this object. Public static void main, because we want to test, right? String args. Let me do something. I will put it here. Okay, how do we start? bnode a equals new bnode a. So first I'm going to create those nodes, which is A, B, C, D, E, F, G, and so on. Just exactly what we did with linked list. A, B, C, D, E, F, G, H. I need 3 more. 1, 2, 3. H, I, J, and K. Oops. A, B, C, D, E, F, G, H. So what I just did, I created those nodes, but I never connected them. So let's connect them. So if you remember linked list, how do we connect node A to its children? And children of A is B and C. B and C. So it's A, it is a root of our tree, has two children, B and C. So A, because it's name of my node, yes, this one. A dot left equals B, which is, that's how we connect. And you remember in linked list we had just next. Now it's not next, it's left or right. And A dot right equals C. Now let's connect node B to its children, and we can see it has just one child, D. D. So B dot right or dot left? Left, because it has just left child. It doesn't have any right child. So B dot left is what? D. So we connected this. Now let's connect C to its children, E and F. E and F. C dot left is C dot left is E and C dot right is F. E and C dot right is F. Now let's connect D to its children, and we see it has only one child, which is right child G. So D dot right is G. We are done here. Let's move on. Let's connect next node, which is E, with its children. So connect E to its children, H and I. H and I. So E dot left is H and E dot right is I. We are done with this node. Now let's move on to the node F, which has just one child, right child G. So connect F to its children, and we just saw it just J. So F dot right is J. Are we done? No, we still have one more node. So we need to connect J dot left with K. So now we connected everything, our nodes are connected. I wish I could prove, but I cannot prove it yet because first we need to learn how to traverse and how to print binary trees, and it's a little bit different. So let's go back to the slides very quick and then we will write those methods. Traversal is a process that visits all the nodes in the tree. Since a tree is a non-linear data structure, there is no unique traversal. That's why we have several orderings for traversals: pre-order, in-order, and post-order. Pre-order, first you process root node, then its left and right subtrees. In order, first you process left subtree, then root node, and then right subtree. Post order, process left and right subtrees, and then a root node. I have some examples here, but I want to show you my example, our example for the tree which we just created. Let me open it. It's here. So let's start with pre-order. First, we process the root, then left subtree, and then right subtree. Pseudocode would be looking like this. If root is not null, print root value, then go to the left recursively and then go to the right recursively. So binary trees, it's like a recursion by nature. It's perfect for recursion. That's why it's always recommended to use recursion. It's much easier to use recursion with trees than iteration. Of course, you can use iteration, it's your choice, but just saying, it's much easier. So here I draw the tree which we just created. It's the same tree. And now let's traverse it using pre-order so you can understand what it actually means. So first we start with the root. And first we need process the root, meaning print root value. So I'm here, I have three options. Each node has three options, if you can see. Print value, go to the left or go to the right. And since it's pre-order, we start with print value. It's here, print root value. So I'm starting here, I'm going to print A. And I'm going to remove this option from the list, so I will not get confused. And now it's saying go to the left. I go to the left, and it's saying print value, which I'm going to do. I print it here. And I'm going to remove this option just so we will not confuse. Now it's saying go to the left. I go to the left, I'm at this node now. And I have three options. I can print, go left and go to the right. But please note it's in order. I do not have really options. I need to choose the first one. So print value, that's what I'm going to do. I print D. I'm going to remove it from the list. So now go to the left, but you can see there's no left. There's no left. So it means I need to go to the right because its only option is left. Go to the right. I'm at the right. And again, I have three options here. Print value, That's what I'm going to do. And I'm going to remove it. Then I need to go to the left. But there is no left. I cannot do what doesn't exist. Then it's saying go to the right, which I cannot do again because I don't have any right child here. So I just remove it from the list, right? So I come back here. Here's nothing to do. We already done everything. I come back to previous node, and it's saying go to the right. But I don't have any right here, so I just ignore it. And I go back to previous node, and it's saying go to the right. And that's exactly what I do. I go to the right. I'm here at node C, and here's my options. So print value, which is C, and then it's saying go to the left. Left is here. Just let me remove it. I'm at the left, and it's saying print value, which is E. So I printed it. That's why I remove it. So it's saying go to the left. Left is here. Left is here, and it's saying print value. I'm going to print this value, which is H. Now it's saying go to the left, there is no left. Go to the right, there is no right. So I just removed it. And recursively, I'm going back to the previous node, and it's saying go to the right. Okay, I'm here, and it's saying print value. That's why I print I. Now it's saying go to the left. There is no left. Go to the right. There is no right. So I recursively go back here. Here nothing to do. I go here, and it's saying go to the right. Right is here. Now it's saying print value. That's what I'm going to do. Print value. Then it's saying go to the left, but there is no left. There's I cannot go there because it's not there. Now it's saying go to the right, and right is here at node J, and it's saying print value. That's what I'm going to do. And then it's saying go to the left, and go to the left, and I'm here at node K, and it's saying print value. So I'm here. Now it's saying go to the left. There's no left, and there's no right, so I cannot do this. And I go back recursively here, and it's saying go to the right, but there's no right. So that's my pre-order. Again, I traversed the entire tree, and I was able to print each value in pre-order. Let's code it now. Just let me copy it. So I'm going to print it here. How? Okay. It was pseudocode which I provided, which we just did. So I'm going to create a method for traversal right here. Public static void. Why is it void? Because we are just printing, we don't do anything else. And I'm going to name it pre-order because that's what it is. With parameter bnode root. Root is going to be my parameter. And we check if it's our base case. Actually, if root is not equals null, so we will call this method recursively until this condition is met. So when root is null, it means we stop. And print root value. So I know it's system out print line, and we literally print root dot value and just some space. Now go to the left. So how can I code this? How can I program this? Well, we know we can use recursion. That's what we like about recursion, that it really helps with trees. So we call this method pre-order with parameter left root dot left. That's how we keep going to the left. And pre-order with parameter root dot right. So this is a method. Public static void pre-order with parameter bnode root. If root doesn't is not equal null, we print root value and we go to the left subtree and we go to the right subtree. Let's run it and compare. And here's our output. Let me go back to our example. That's what we got. ABD, G, C, E. So it's the same. One we did with the code, and the second one we did by hands. So again, what's important to understand about pre-order? First, it processes the root, then left, and then right. But what about in order? For in order, first you process the left subtree, then root, and then right subtree. So pseudocode would be looking like this. If root is not null, go to the left, then print value, and then go to the right. And let's do it together. So it's the same. I have the same tree, and each node has 3 options, and I need to follow the order. I cannot choose just a random one, right? So start with the root. Our root is A, and it's saying go to the left, which is here, and it's saying go to the left. I go. I'm at node D. Go to the left. I cannot go to the left because there is no left. So what else I can do? Print value, and I'm going to print D. Now it's saying go to the right. I go to the right, and I'm here at node G. Node G says go to the left. Oh, sorry, it's not this one. Go to the left. There's no left. Then, so I just ignore it. Then print value. I'm going to print it. And then go to the right. There is no right, so I ignore it. Recursively I go back. There is nothing to do. I go back, and at node B it's saying print value, and I'm going to print value B. Once I print it, I need to go to the right, but there is no right because node B doesn't have right child. So recursively I go back to the previous node, and it's saying print value, which I do, and then it's saying go to the right, and I go to the right. That's how I got to the node C, and it's saying go to the left. Let me remove it from the list. Go to the left. I'm here, and it's saying go to the left. I go to the left, and I'm here, and it's saying go to the left, but there's no left, so I just ignore it. And then it's saying print value, and that's exactly what I'm going to do, print value. Once done, it's saying go to the right, but there is no right. That's why recursively I come back to previous node, and it's saying print value, and I print E, and then it's saying go to the right, which I do. It's node I, and it's saying go to the left. I cannot go to the left because there is no left, and it's saying print value. I can do that. I print value, and then it's saying go to the right, but there is no right. So recursively I go back, and it's saying I didn't remove this, and there is nothing to do. And here it's saying print value, so I'm printing C, and now it's saying go to the right. I go to the right, which is node F, but once here it's saying go to the left, but there is no left, so I just ignore it. Then print value, and I print F, and it's saying go to the right. I go to the right, but it's saying go to the left, so I go to the left. Just let me remove it. Go to the left. I am at the left, and it's saying go to the left again, but there's no left, so I just ignore it. And it's saying print value, so I print K here, and it's saying go to the right, but there's no right, so I come back here to previous node, and it's saying print value, and then go to the right. I print value, but I cannot go to the right because there's no right. And you can see I'm done here. Here's my output of the method. Just let me okay. Let me write another method. Public static void in order takes bnode root as a parameter, and the same base case. If root is not null, doesn't equals null, go to the left, remember, go to the left, then print value, and then go to the right. Of course, it's in order. Yeah, it looks good. Now let's print in order. Our root is A. It was in order. Pre-order. Compile, run, and this is in order. Pre-order and pre-order and in order. I hope you can see it. And that's what we did by hand. That's exactly what we have. Magic? No, not magic. Recursion is not magic. So you need to understand how to do it both with the code and with the hand. And let's do another one, the last one, which is post order. And last order is post order. First we process left subtree, then right subtree, and then root. And here's our pseudocode for this. If root doesn't equal null, go to the left subtree, then go to the right subtree, then print root value. So let's start. We start with a root, and it's saying go to the left. Okay, we're here, and it's saying go to the left. We are here, and then go to the left. We're here, and now we cannot go. Okay, where is it? Yeah, we cannot go to the left because there's no left. So it's saying go to the right. Then I go to the right, and it's saying go to the left. There is no left. Then it's saying go to the right. There is no right, so I just ignore it. And then it says print value. So I'm going to print value here. Remove. There's nothing to do, so recursively you go back. The only thing to do is here is to print value. That's what we're going to do. Go back. It's saying go to the right. I cannot go to the right because there is no right. I just ignore it. And then it's saying print value. So I'm printing B here. There's nothing to do anymore. So recursively I go back to previous node, and it's saying go to the right. I go to the right. I'm here, and it's saying go to the left. I go to the left, and it's saying go to the left. So I go to the left, and it's saying go to the left, but there's no left. I ignore it. It's saying go to the right, but there's no right because it's a leaf. And it's saying print value. So I'm going to print H here. There is nothing to do anymore. I go back, and it's saying go to the right. I go to the right. Just let me remove it. Okay, I go to the right, and it's saying go to the left. I cannot go to the left because there is no left. Go to the right. I cannot go to the right because there is no right. Then print value, which is I. I print the value. I go recursively here to the previous node and it's saying print value. So I print E here. I go back recursively and it's saying go to the right. I go to the right and it's saying go to the left, but there's no left because F doesn't have left child. So I ignore it. And then it's saying go to the right. I go to the right and it's saying go to the left. I go to the left and it's saying go to the left, but there is no left. It's saying go to the right and there is no right. It's saying print value. So I print K here and just go back. And it's saying go to the right. Oh, I didn't remove it. Oh, yeah, go to the right. There is no right. I remove it. And then print value, which is J. I go back recursively here and it's saying print value. So I print F here. There is nothing to do anymore. I go back and it's saying print value, which is C. I go back recursively and it's saying print value again here. And that's it. I traversed the entire tree. Now let's code it. That's the output I'm expecting. Okay. Public static void post order bnode root, and basically it's the same. If root doesn't equal null, not bool, null, we go to the left recursively, so post order, we process left left subtree, then right subtree, and then we process root value, we print it. Okay, and this is my method. Let's test it. Post order. Post order with parameter A because it's our root. Run. And that's our output, and that's what we got by hand. So it was a lecture about binary trees, how you can manipulate nodes, how you can link, how you can create a tree, and of course how you can traverse it using pre-order, in-order, and post-order. It's important to understand. I might ask you something like this on the exam or quiz or lab assignment. And in the next lecture, we are going to cover binary search trees and some binary trees methods, like search, add, and so on, remove, and so on. Let me know if you have any questions about this lecture. I will be glad to help you.